In this part of math, we are going to talk about functions and relations. And we are talk about also about composition functions. And we'll talk about asymptotes, vertical and horizontal asymptotes of a function. And also you're going to understand how to find the graph of an inequality. Okay, if I have pairs 2 and 3, and I have 5 and 8, and 3 and -5, and I have 2 and 8. As you see, these ones now they represent pairs, and in each pair it represents x and y, and x represent domain and y represent range, right? So that means xy, xy, xy. Good. These numbers now are random numbers for x and random numbers for y. Do they represent a function or do they represent relation? Okay, look, if these numbers now, I can make for them rule like y equals as a function, y equals here. In this case, it's going to be a function like y equals 3x plus 2. So that means all of them, y is given based on a rule from x. Okay, in this case, if all of them, they have the same rule here in this case, I call them function. But if they are random and everyone increases or decreases or different from the way that x came from, in this case, we call it relations, but not functions. So this one is a relationship between x and y, relations. So these ones are relations between x and y's, but they are not what? Function. And how do I know exactly if the numbers, these ones, I want to make sure that these ones are not a function. If you have two values of x, and they have different values of y. Look, here the 2 of x, it has 3 of y, and here the 2 of x, it has 8 of y. So especially if you have one value of x, it has two values in x. Here you made sure that these numbers, they don't represent a function, but they represent what? A relation. Okay, if I have a table now, I give you just another example. If I have here these ones, x and y, they represent the same pairs, but I write them what? Or I draw them in a table. If I have here 1, 2, 3, and here I give you, for example, 3, here is 5, and here is 7, okay, here is 4, and you expect this number, then we would. Okay, look here now. For this example now, this 1 and 3, I can write it 1 and 3, and here I can write this one 2 and 5, you see? And this one I can write it 3 and 7, right? And so on. These relations, of course, it is relations of x and y. It is relation. But now, is it function or no? Is it function or not? I need to know if they go into a specific rule. That means the y value is found by same rule in all of them. In this case, it's going to represent what? A function. Okay, so look here now. The rule of this table, by the way, it is 2x plus 1. It is 2x plus 1. That means you multiply the x value times 2, then you find 2 at 1. Look, this is now x value. It is 1. Multiply it by 2, you will get 2. Plus 1, you will get 3. Same thing here. This is 2. Multiply it by 2, it's going to be 4. Plus 1, it's going to be 5. Here times 2, it's going to be 6. Plus 1, it will give you 7. So as you see, all of them, they go after this function, after this rule. So that means this one now is a function. And if you have a function, you can estimate even greater numbers. That means now if x is 10, if x is 10, what will be y? If x is 4, same thing, 4 times 2, it's going to be 8. Plus 1, it's going to be 9. Okay, if x is 10, also apply it here. Apply it here. When x is 10, x is 10, like x here 10. 10 times 2 is 20, plus 1 is going to be what? 21, and so on. So this is what? Function. And the function here, which is I write it y also you can write it like f of x, which is function of x. Function of x, it means y. Good, it can be written as y or f of x. F of x here, it equals what? 2x plus 1. Okay, look. if I tell you now, if I tell you based on this one here, based on this function, find me f of 5 or f of 3. Find me f of 3. Function of x, look, function of x, this is a general rule. Function of x, that means for any number for x, this is how to do. Multiply the x by 2, then times 1. Okay, now when I tell you function of 3, that means when x is 3 now, that means instead of this place, look, instead of x here, when x is here, you write here x. If here is 3, you write here 3 instead of x. So that means f of 3, it's gonna be 2 times 3, you see, plus what? Plus 2. So that means it's gonna be what? It's gonna be 2 times 3 is 6 plus 1 what? 7. So that means as you see it is here what? 7, which is function of what? Of the 3. So that means function, it is a general rule here. It is a general rule, and you can use it to find function of any number. Okay, if I tell you now what is function of 5, function of negative 5. Same thing, function of negative 5, apply it here, apply the 5 here. So it's going to be 5 times 2, it's going to be what? Negative 10. Plus 1, it's going to be what? Negative 9. Okay, if I tell you now, find f of x plus 1. Look at this question now. F of x plus 1. That means now, instead of this x now, what I need you to put instead of x that is here? You put x plus 1. X plus 1, you put it here. So that means f of x plus 1, it's going to be instead of each x, you write x plus 1. So that means f of any number, it means plug instead of x in that whole equation, this number. So that means it's going to be instead of it is now 2x plus 1. Instead of x, we write what? This value, which is x plus 1. So that means we write here, instead of x, we write x plus 1. You see? In a bracket, then plus what? 1. Then here, 2 times x is going to be 2x. Then 2 times 2, it's going to be 2 plus what? Plus 1. So that means the final answer is going to be 2x plus what? Plus 3. And this is the f of x plus 1. And I hope that is clear. We understand now functions, how we do them, and what do they represent? They represent y value when x value is given and the rule is given as a function. In this case, we find the y value of x based in that way. Okay, if I tell you now y, or I tell you here g f of x or g of x here, I'm going to give you both of them. If I tell you now f of x equals 2x, good, and g of x equals x plus 1. Then I find you here now, look, I'm going to give you many questions. Question number one. Okay, this one just, it is plus 1. It was here plus 1. Get x plus 1. Okay, if I write you now a question that find, number 1, find f of 2 minus g of 2. You see? F of 2 minus g of 2. That means now f of 2, I'm talking about the function f, not the function what? G. So that means instead of x, you write 2. So instead of here x, it's going to be 2. So 2 times 2 is going to be 4. So that means this one represents what? 4. Minus g of 2, that means instead of x, you write 2. It's going to be here 2 plus 1, it's going to be 3. So that means minus what? 3. So the answer will be 1. So that means equals here what? 1. So f of 2, that means substitute instead of x 2 in the function of x, which is f of x. Then g of 2, it means replace x by 2 in the function g of x, which is what? There. Then it's going to be what? 2. So you understand now here how to find f of x minus 2 of x, where sometimes I write 2 times 2 or minus or whatever. Okay, so that means the answer here equals what? 1. Okay, if I tell you now, find me number 2, find me f of x, I can write you f of 2 or f of 2 or f of 3 or f of 5 over g of 2. You see, I can write it. So you substitute 5 in here to find it, which is 10, then you put it here, then you find 2 there, it's going to be 2 plus 1, 3, so then it's going to be 2 of 3, then let me see, write it. So we can write this one here when it is times or plus sometimes or minus or times. You write it just after what the substitution. Now we're gonna take what is the composition functions or function of x, g of x when you have two of them. Okay, if I write you now, look what I write you. I write you now, find me of g of x. You see? What do I mean now? I mean now, in the function, the main function, which is f of x here, replace instead of x the function that is g of x. And what is the function that is g of x? This one, right? You see it? So put it here instead of x. That means it's going to be instead of x here. You see? Instead of x, it's going to be exactly here. So what will I get now? This is 2 times x, right? And instead of x, I'm going to write what? G of x. What is g of x? Which is x plus what? Plus 1. So what will be the result now? It's going to be what? So that means f of g of x, okay, it's going to be what? 2 times x, it's going to be 2x plus 2 times 1 is 2. So this is the answer now. Okay, to make sure you understand, I'm going to give you now another question. Question number 3. I'm going to write you, find me g of, look, g, parenthesis of f of x. This one is different now. I mean now in this case, go to the main function, which is what? G, right? Okay, g of x, get this one. And replace instead of x, the function what? F of x, all of it. What is f of x? F of x is the 2x. So you write it instead of x here. What do you get? As you see, that one, it is x plus 1, which is g of x, right? And instead of x now, I erase the x and I write its value, which is what? F of x. What is f of x? F of x is what? As you see, f of x is what? Is 2x. So that means the answer will be 2x plus 1. But I need you just to give you one more note. Look, I give you one more note. F of g of x, I can write it like f composition log of g of x. Of g of x. You see how you write it? So this one here, it means this one. You get the same thing. Here, the other one, g of f of x, I can write it like g of f of x. And I hope that is clear. I hope that is clear. And you understand what does it mean? It means now here you compose one function inside the other. And I hope that is what? That is clear. Okay. We have something called integer function or floor function. Floor function, look, if I have here a number that is 3.5, this is a function. That means now this is x and y, to find y. So that means if I have a function y equals composition, I mean this one is brackets, square bracket of x, it means here integer function, or it means floor function. An integer function means it change the x when it is, it means it change x when it is decimal to be integer. To be what? To be integer. That means I need the number which is like a quotient or irrational number, I need it just to be exactly what? Integer. And what integer now? You need to go left. You see here now, imagine this number which is 3.5. Imagine where is it in the number line. If you remember the number line here, as you see here, 0, 1, 2, 3, right? Here is 4. Remember now, where is that 3.5? 3.5 is here. Now, wherever the number, the integer function is to go to take the integer number that is on the left. That is on the left of that number. So here is 3.5. 3.5 is not integer. So what is the integer that is on the left of that number? It's 3. So that means here you write it equals what? 3. Okay, if I tell you now, negative 1.2. 1.2. So what is it going to be now? Imagine now, where is 1.2? This is, as we know, this is 1, negative 1, and this is negative 2. Where is now negative 1.2? It's going to be here, right? Here it's going to be what? Negative 1.2. Now, when I take its integer, I take the number, as we said, the integer number that is on the left of it. And the left of it, which is what? What is the left of this number? As you see, the left number is what? -2, which is an integer. So that means we take here the greatest integer that is less or equal than the number given. And I hope that is clear. Okay, now we move to the next point, which is this point now, is what are the asymptotes and how we know the function if it has asymptotes or not. Okay, just remember something, and I hope you can. And you know, this is x, you are, and here is y, as we know. Any vertical line you want to draw a vertical line on x and y axis, any vertical line, its function will be x equals the number that crosses the number. So that means here is, if it crosses on 3, so that means this one is x equals 3. And any horizontal number, by the way, its function always, its equation will be y equals, where does that number crosses the y? Here, for example, 5, so that means y equals what? 5. So any horizontal number, any horizontal line, its equation is y equals a number. And any vertical line, its equation always, any vertical line and only horizontal line. Any vertical line, its equation is x equals that number. And I hope that is clear. Okay, why do we need these ones? We need these ones to know what are asymptotes. So if I have a function, and you know the function, it has a graph. It has what? A graph. Like if I have this graph now, which is exponential function. Good. That means any function now, it has a graph. And this graph now, it crosses something. It goes in relation between x and y as a function, as a rule. But here now, sometimes it has an asymptote. An asymptote, that means a number that this graph of a function can never cross. Like here, this is the exponent, we call it what? Horizontal asymptote. Horizontal asymptote is a line, or is a horizontal line that this graph of a function can never cross that asymptote. Is that clear? So that means it's like a limit, or that cannot be crossed. This is what's mean asymptote. So sometimes we have horizontal asymptotes and their function always will be y equals a number, and sometimes we have vertical asymptotes and that will be, or its function will be x equals that number. Okay, if I give you now a function f of x, or it can be written y, f of x equals 3x plus 8, look, or x squared, whatever, okay, okay, x squared plus 8x. As you see, if it is just like this now, it is polynomial function. In this case, polynomial function, it doesn't have asymptotes, neither on the y axis or on the x-axis. But if I put it as fraction here, as quotient, and I give you here x minus 3. In this case, now when I go to graph this function now, when I go to graph the function, they will not give you the graph sometimes, they give you the function. Then they ask you, is this one now, does this one has vertical function, vertical asymptote or no? And does it have horizontal asymptotes or no? And find their equations. Okay, how can we find now horizontal and vertical asymptotes? Okay, vertical asymptotes, remember that thing. For vertical asymptotes, always the function has a vertical asymptote, and vertical asymptote, that means line, vertical line, and vertical line, its equation is x equals a number that makes the denominator 0. So what number here will make this denominator 0? What number I put for x and make the denominator 0? It's going to be 3. So when x is 3 here, 3 minus 3 will be 0. So that means x is 3 is what? Is the vertical asymptote of this function. I hope it's clear. So that means any quotient, any function like a quotient, it has a vertical asymptote. This vertical asymptote, its function is x, its equation is x equals the number that will make the denominator 0. Good. What about horizontal asymptotes? Okay, look, for vertical asymptotes, we have only one rule. X equals the number that makes the denominator 0. Done. Okay, what about for horizontal asymptotes? You have 3 rules. Look, rule number 1. If the power of the numerator is greater than the power of the denominator, look, I'm talking about the greatest power. In this case, no horizontal asymptote. Keep it in mind. Okay, here now, if you apply it in this question now, what is the highest power in the numerator? The highest power is 2. What is the highest power in the denominator? The highest power in the denominator, it's 1, and it's not written. So in this case, if the highest power of the numerator is greater than the highest power of the denominator, no horizontal asymptote. Good. What about if they are equal? Okay, this is now another one. What about if I have a function like this? Look, function of x equals 3x squared plus 5 over 2x squared plus 1. As you see here now, the highest power of the numerator is 2 and the highest power of the denominator is 2. So if the highest power of the numerator equals the highest power of the denominator, in this case, it will have a horizontal asymptote, and this horizontal asymptote will equals y. As we know, any horizontal asymptote is y equals. Now this y, it will equal the coefficients of these powers. Here is 3 and here is 2. So that means it's going to be 3 over what? Over 2. Like you divide just what? You divide the coefficients of these highest powers of the denominator and of the numerator. So y equals 3 over 2. Okay, third rule is when here I give you an example, when f of x equals 3x power 2 over 2x plus power 3 plus 1. So in this case now, the highest power of the numerator is 2 and the highest power of the denominator is 3. So in this case now, the power of the numerator is less than the power of what? Of the denominator. In this case, it will have what? It will have a horizontal asymptote, and this horizontal asymptote y equals 0. Always if the power of the highest power of the denominator, which represents the degree of the denominator, is greater than the power of the highest power of the numerator, in this case, the horizontal asymptote will be y equals 0. So you have 3 rules for horizontal asymptotes, and we have 1 rule for vertical asymptotes. Here now we finished the second point. We'll go now to the last point, which is how we graph the inequality. How we write the inequality on x and y. If I have here y greater or equal than 2. Okay, we understand if it is y equals 2, we understand how to graph that line, right? We said y equals 2, we understand it. If it is horizontal line or vertical line, we understand. But if it is now not y equals 2, it's y greater than 2. In this case, now look what you're going to do here. This is now y, and this is x. And we change to graph this one now. The goal is to graph y greater or equal to. Good. How we graph this one? First step, we read this one as equation, not as inequality. So you read it like equal. So we read it y equals 2. And when we read it y equals 2, how we graph y equals 2? Y equals 2, it is a horizontal line that crosses the 2 of the y. So that means this is the line. Okay, good. That means this is now the line. And look, if it has equal, keep in mind, if it has equal here, so the line has to be solid, like this one here. Good. This is the first step. Second step now, if it is inequality, you need to shade. You need to shade either above the line or below the line. And this is extra point, which is more than the equation. This is for inequality. Good. Now, when I tell you y is greater or equal than 2, that means I'm talking about the y that is above the 2 or below the 2. Logic. I'm talking about the y that is greater or equal than 2. So I'm talking about all these values of y. So that means you shade this place. So this place will be shaded. In this case, y is greater or equal than 2. It is area. It is the region of solution. It's not one solution. It is the region of solutions. That means many points will satisfy this inequality. So any point now that is greater than 2, it will satisfy what? This inequality. Okay, I'll now graph another point, another equation. If I tell you now, instead of this equation, just if I erase now, instead of, look, greater or equal, I'm gonna write it like y greater than 2 only. There is no equal here. So in this case now, first step to graph this one, or read it as equation. You read it y equals 2. Now, when you read it y equals 2, that means I graph this line here on the y equals 2. But look, is there equal here? There is no equal in the question. There is no equal here, it's just greater than 2. So the 2 is not included. Y is greater than 2, that means the 2 is included. It's not included. So in this case, you write dashed line. You see? You write the line as dashed line, not solid line. Then you shade, above what? Above the line. Here is shaded. Okay, this is now the second point, second idea. Okay, what about if this now when it is greater than? Okay, what about if it is less than? What about if it is less than? If I write here, instead of greater, just I change it to be what? Less than. This is now less than 2. Okay, if I make it less than 2 or less or equal to, the difference just is dashed line or solid line. That's it. So that means if there is no equal, it is dashed line. When there is equal, that means it is solid line. Okay, if I make it now less than 2, how do I graph this one? First, I read it like y equals 2, and I go to the 2 here, and I draw a line. This line now has to be dashed line because it is less than. I drew here dashed line. Okay, what's next? Where do I shade now? Above the line or below the line? I'm talking about y when y is less than 2. So where is y less than 2? Y less than 2 is in this area. So this is the area of the solution, and the area of the solution is region of solution. As we said, it's not one point of solution. So any point now here, any point in this area of solution, any point here on the shaded region, it satisfies this inequality. This is now, I draw the inequality when it is y less or equal or greater or equal than 2. But what about if it is instead of y, it is x? Same thing. If it is x now, just same thing. If this one here is x, imagine here, or as you see here, this is x less than 2, or x less or equal than 2. In this case now, and it's gonna be x. When I read it x equals 2 when I draw the first step, which is line. And x equals 2, this is vertical line. So that means I go to x equals 2 here, and I draw a vertical line. And just I want to check, is there equal? Yes. If there is equal, that means it's going to be a solid line. You see? Solid line. Now, x is greater than the 2 or less than 2. X is less. So less left or right? It is left. So that means I shade this area, which is on the left of the 2. That means any point now inside this one, inside this region, it satisfies the equation. Okay, last point related to the third part of the lesson of today is what about if I have this, instead of this one here, I'm gonna give you x plus y less or equal to, for example here. How do I graph this line? How do I graph this line? Okay, you have to move it in a step. First step, change it to be equation, not equality. Okay, change it to be equation, so then it's going to be x plus y equals 2. Second step, make it in terms of x and y. So make the y the subject. So it's going to be y equals x plus what? Plus 2. No, when you send x there, it's going to be negative x. So that means negative x plus 2. Now find the slope and the y-intercept. As you see, it is the same like equation y equals mx plus b. In this case, the b, which is y-intercept is 2, and the slope, which is m, equals what? -1. Now I go to graph the line. How I graph the line now? I go to see where is the y-intercept 2. The y-intercept here is 2, you see? And now from this one here, rise is here, -1, it means -1/1. So that means it's gonna be now, you go run 1 and rise 1, but on the left side. So you go 1 step here, then you go up here 1 step, and you have here another point, and this point now I grab the line, you see? So this is now will be the line. Okay, why I draw the line solid, not dashed line? Because I have here equal. Okay, now I finished now grabbing the line as equation, but what is given for me is an equality. And an inequality, it has just one more step than equation. That means it has just a region of solution, not just a line of solution. That means points are in the region. So now I need to shade either above the line or below the line. How do I know? How do I know whether I should shade here above the line or below the line I shade here? How do I know? In this case, just look what to do. Take a point from the region you want to shade. I'll take this point, you see? And you want to check this point as unit is 0 and what? And 0. I want to check if this point now satisfies the equation. That means this point is inside the solution region. When it is inside the solution region, so I shade here. But if it's not satisfies the inequality here in this case, so that means it is not in the region of solution. So that means the other side will be the region of solution. Okay, now I substitute here 0 and 0. When I substitute here 0 and 0, you're gonna be 0 plus 0, 0. 0 less than 2? Yes. 0 is less or equal than 2. So that means this one now, since it is satisfied, so that means this is now the area of what? Of solution. So I shade what? This area of solution. That means now, any point here, any point in this area, you see, any point, wherever is the x and y, it will be satisfied by this inequality. But any point here will not be satisfied. So if you choose point here, like 5 and 5, you see, if you choose it here and you put it here, 5 plus 5 is 10. 10 less than or equal to? No. So that means any point on the other side that is not shaded will not be satisfied for this inequality. So I hope you understand now how to shade, and also on the test and on the questions of the quizzes, there is a choices. When there is a choices, they give you the point. When you give you a point and they give you the shading, you just pick a point and check if it satisfies the area of the solution or not. Thank you so much. See you in other videos.